Hello everyone, I welcome all of you again to the series of Work and Time. I hope all of you are doing well and focusing on your exam preparation. In this lecture, we will learn the new concept, the new type of question, that is negative work. This concept, this type of question is quite similar to the first one. Which was the first type of question we have discussed? Efficiency of individuals. Okay. So what do we understand by negative work? What do we understand by negative work? Or what do we mean by the negative work? So let's come to the blackboard and understand. Negative work means suppose if a person A and B are there. Okay, so person A is trying to build a wall and he say arrange 4 bricks per day, where when B's turn on B's turn, B remove 2 bricks. So A is building up and B is removing bricks. That means B is doing negative work. Okay, because the objective is to build the wall. Okay, objective is to build the wall and B is doing the opposite work. Alright, I hope that is clear to you. Right. So with this, let's see the first question. Our first question say a pipe can fill a tank in 12 hours. Due to leakage at bottom, it is filled in 24 hours. So there is a tank and a tap is able to fill this tank in 12 hours. But there is a leakage at bottom. Because of which it's going to take more time, right? Now, who is doing the negative work? Which one of them is doing the negative work? Pipe or the leakage? Of course, leakage. So leakage is removing the water. So leakage is doing negative work. So let's see how do we handle this question. As I said, this is very similar to efficiency of individual, that type of question. Okay. So here first we assume the work. You remember in that first type of question, or here if you remember, we used to assume work as LCM of time. We are going to do the same thing here. So time is what? 12 hours and 24 hours. 12 hours and 24 hours. So I will assume, let's say the work here is LCM of 12 and 24. 24 is common for both of them, right? Now in this case, in pipe and cistern, the work will be capacity of tank. What is the work? Work is to fill the tank, right? So total work is to fill the tank till top, right? So here in this case, work will be capacity of tank, and for capacity of tank, I can use the unit what? Liters, right? I can use the unit like what? Liters. So I will assume the work is 24 liters. So I will say the capacity of tank is 24 liters, right? Okay. Now understand. Pipe can fill a tank in 12 hours. Due to leakage, that means pipe and leakage, both of them working together, it's taking 24 hours. So see how do I look at this situation. Let's say pipe is P, right? Now total capacity is 24 liters. How much time pipe is taking? 12 hours. So what should be pipe's efficiency? Efficiency is what? Work upon time. Remember, efficiency is what? Work upon time. What is work here? To fill a tank having capacity of 24 liters, which a pipe is taking 12 hours. So per hour work for pipe should be 24 by 12. That means pipe efficiency is to fill 2 liters water per unit time. What is the unit of time here? Hours. So 2 liters per hour. That is the efficiency of pipe. Very similar to first type of question. Yes. Perfect. Okay. Now due to leakage, so here pipe and leakage, both of them are working together. Now earlier, when two people used to work together, we used to add their efficiency. But because of the negative work, I will subtract the efficiency of leakage. So I assume the efficiency of leakage to be L. Pipe efficiency is P. Alright. Now together, they are taking how much time? 24 hours. That means the efficiency of pipe and leakage together should be total work, which is 24 liters, the capacity of tank, by time they are taking to complete this work, which is again 24 hours, right? So this will get you what? 1 liter per hour. That's the efficiency when they are working together. Now, if you understand this, and I'm sure you must have understood. If not, then I suggest to revise the lecture number 1 and lecture number 2 of work in time. You will get to know what am I doing here. Okay. Now, if I have this, so pipe efficiency is what? 2 liter per hour, and pipe in presence of leakage, it is 1 liter per hour. So what should be the efficiency of leakage? If I say equation number 1 and 2, although it's very obvious, if pipe efficiency is 2, how much will you subtract to get the total efficiency 1? Obviously 1. Yeah. So leakage efficiency should be what? 1 liter. Or you can substitute pipe P equal to 2 here, P minus L equal to 1, and find the value of L. You will still get the L equal to 1. Yeah. So what is L? What have we assumed as L? L we have assumed as the efficiency of leakage. Efficiency will be in terms of work unit per unit of time, right? Okay, so leakage efficiency is 1 liter per hour. Now question is, if the tank is full, how much time will the leakage take to empty it? How much time will a leakage take to empty it? Okay. So if only leakage is working, how much time it will take to empty the 24 liters of water? That's the capacity of tank we have assumed. Yeah, that's the capacity of tank we have assumed. Right? So what should be the answer? Time equal to work upon efficiency. So it's going to take 24 hours to complete the entire work, isn't it? 1 liter per hour. You need to empty 24 liters, so it's going to take 24 hours, right? Simple. Yeah, so the only difference in the question we have seen in lecture number 1 and 2 and this is, here you got negative work. Here you got what? Negative work. All right. Okay. I hope you understood the question. Let's see the next question. Next question here is, 2 inlet pipes can fill a cistern, tank, one of the same thing, in 10 and 12 hours respectively. 10 and 12 hours respectively. Okay. An outlet pipe can empty 80 gallons of water per hour. Guys, here you already have the efficiency of the outlet pipe, because that is work unit per hour. Yeah, per unit time per hour. So let's say the 2 pipes, the inlet pipe, let's assume to be A and B, and the outlet let's assume to be C. So C capacity is already given, C efficiency is already given, that is 80 gallon per hour, right? 80 gallon per hour, correct? Yeah, I hope you understand this. So we already have the efficiency. Now in this case, what do we do? Can we go with the same method, assuming work as LCM of time? No, we cannot. Why do we have to assume the work as some value and then go next? Because why do we have to do that? Because we need to find their efficiency. If one of the efficiency is already given, I cannot I cannot assume work as any number. I cannot assume work as any number in such case. Shall I repeat this for you? We assume work as a number for shortcut. So why do we assume work as a number for shortcut? So that we can find the efficiency. But in this case, the outlet pipe efficiency is already given. So can I assume work as some number? No. I hope that's clear to you, right? Assume work as a number? No. So what do we do in this case? We'll assume work as a variable. Simple. Yeah, because that is what we need to find out. See, in the pipe and system, just now in the question number 1 we have discussed, the total work we assume is the capacity of the tank. Yeah, the capacity of cistern, tank, right? That is what we need to find. So how can I assume that as number already? I hope that's clear. So this I have to assume as a variable, right? So I will go with the first method, assuming work equal to x, that we have done in class, the first lecture of work and time, right? Look at this, look at this. You will still find this question and explanation easy, because I'm sure you have gone through the video number 1 and 2. So if I assume work to be x, that means the capacity of tank is x, yeah, x, and it's in gallons, so x gallon, yeah. Capacity of tank or work is one of the same thing here in this particular case. Now, 2 inlets pipe. So what do we do after assuming work? We look at their efficiency. So pipe A's efficiency in this case, pipe A's efficiency will be work upon time taken, that is 10, right, 10 hours. And pipe B's efficiency will be work upon time, that is 12 hours. So please learn this, understand this. To attempt such kind of question, first you need to look at the work. After finding out the work, then look at their efficiency and then make equation as per the question, and it's straightforward. You will get the answer. Okay. What is the efficiency of C? Given 80 gallons per hour, right? Okay, now when they are working together, A is the inlet pipe, B is the inlet pipe, but C is the outlet pipe. So C is doing negative work, removing the water, right? Equal to their efficiency, total efficiency, right? Now with the total efficiency, question said they will be able to complete the task, empty the cistern. Okay. All the pipes are working together, can fill the empty cistern or empty tank in 12 hours. So what is together efficiency? Together efficiency is again what? Work upon time. Are you getting it? Together efficiency, A's efficiency plus B's efficiency, and because C is removing the water, so negative work, so minus C should be representing the efficiency together. And by the way, what is the efficiency together? Efficiency together is work, which is x, divided by time, which is 20 hours, right? That's how you get. Okay, I hope this part is clear. Yeah, I hope this part is clear. I hope I'm not confusing you guys. Yeah, efficiency, remember this. For efficiency, work upon time. Yeah, remember this. And then just substitute the values. Come on. X upon 10 plus X upon 12 minus C's efficiency, that is 80 gallons per hour. Anyways, that's equal to X upon 20. Now it's only simplifying this equation. So simplify this equation. Come on, simplify this equation. What do you get? X upon 10 plus X upon 12 minus X upon 20 equal to 80, right? So I can take X common and I can take X common and I can say The LCM, how do you simplify LCM? 10, 12, 20. I can say LCM is, let's say 60. Okay. Yeah, 60. So 10, how do you make the first denominator 60? Multiplying 6. How do you make the second denominator 60? Multiply by 5. How do you make the third denominator 60? Multiply by 3. Alright. So what do you do here? 6 plus 5 minus 3 equal to 80. Simplify further. Yes. Come on, get me the answer. Simplify further. X equal to 80 into 60 and 5 plus 6, 11 minus 3. That's how much? 8, right? Simplify. Cancel this out. Yeah, cancel this out. What do you get? What do you get? X is equal to 600 gallons, right? That is the total capacity we have assumed. So X is equal to 600 gallons. That's your answer. Okay. So we got an example where which give us a clarity that when not to assume work as a number. Yeah, that's why it's important to understand all the methods. I have told you in ratio and proportion topic also, and I am telling you now also. As you understand all the methods, so that you never know which method will be applied in which question. Okay, fine. All right, let's see this. Next question. Okay, so now you are clear with negative work. I advise you to pause this video and try attempting this question. Okay. Okay, let's see. Are we getting the same answer? Solution. Read the question. Read question carefully. Okay. I have my formula. Read questions, and in exam if you're solving, look at the options and I read question again. So I'm able to relate and I'm able to understand whether I can apply any shortcut or not. That you will be able to do when you read questions. Read question, look at the options and again read question. You will be able to find out whether you can apply shortcut or not. Okay. So two pipes A and B can fill a cistern in 3 hours and 5 hours respectively. Pipe C can empty in 2 hours. Alright. So you have only time mentioned here, correct? If all 3 pipes are open, how many hours the cistern will be full? In how many hours cistern will be full? So only time is mentioned here, right? So I can again take work as the LCM of the numbers, LCM of the time. 3, 5, 12. What will be the LCM? Here 30. Okay. What is the work in this case in pipe and cistern? Okay. For this particular question, the work is always capacity of tank, capacity of cistern, right? And we can assume that into liters. So let's say the capacity of cistern is 30 liters. Capacity of cistern is 30 liters. All right. Okay. So let's solve. So you got A, B and C working together. Can I skip some steps? Yeah, I hope you allow me to do that. What will be A's efficiency? A is taking 3 hours to fill 30 liters. What will be A's efficiency? When they are working together, it will be A plus B minus C, right? What will be A's efficiency? Come on. What will be A's efficiency? 30 upon the work upon time. You make me write. You make me write all the steps. Come on, that's not good. For B, it's 30 upon 2. And for C, it is 30 upon, for B, it is 30 upon 5. 5 hours for B. And 30 upon 2 because 2 hours for C. And that will get you 10, 6 and 15. So you will have 1. What is this one? The efficiency when all 3 pipes are open. efficiency. What will be the unit of efficiency for this particular question? It will be work unit, that is liters per unit time. What is time value unit here? Hours. So 1 liter per hour. Okay. Now, what's the question? If that's the case, how much time will they take to fill the tank? Come on, if their efficiency is 1 liter per hour, then how much time will they take to fill 30 liters? It will be 30 hours. Do you find this to be challenging? 1 liter per hour, 30 liters you need to fill. It will take 30 hours. Yeah, simple. Yeah. Do not keep applying formula everywhere. I hope you are not doing that. Yes, I know my students are intelligent. I appreciate that. Okay, with that, let's look at the next question. Okay, the next question here is, a tank can fill by a pipe A in 2 hours. Guys, pause this video, look at the question, try solving it by yourself. A tank can fill by a pipe A in 2 hours, pipe B in 6 hours. At 10 am, pipe A is open. Only pipe A is open. At what time will the tank be filled if B is opened at 11 am? That means after 1 hour. After 1 hour, right? Okay, let's see. Let's see how is it going. So 2 hours and then it is 6 hours. All right. Yeah, I will assume the tank's capacity or the work, or I will say tank's capacity work here in such questions is one of the same thing. That is 2 and 6. So I will take the LCM. Let me say that's 6 liters. That's the capacity of the tank. Okay. A's efficiency is 6 by 2 work upon time, that is 3 liters per hour. What about B? B's efficiency will be 6 upon 6, that is 1 liter per hour. Alright, that's clear. Now question said for 1 hour only A is open. How do I know only 1 hour? Because it says it is open at 11 am and then it's open at 10 am and then at 11 am B also open. Okay, B also open. So A is working alone. The pipe A is open and running alone for 1 hour, right? So what is happening in that 1 hour? So from 10 am to 11 am, what is happening? In that 1 hour, A is able to fill how much? What's the efficiency of A? So 3 liters per hour, right? So how much water A will be able to fill? 3 liters. Correct? Because here only A is open. Okay. So at 11 am, the tank is filled with what? 3 liters of water, right? So how much is remaining? How much is remaining? How much is remaining? Come on, how much is remaining work? The remaining work will be the work minus the work done in this 1 hour. That's how much? 3 liters. So you still have to complete the remaining 3 liters. Now for post 11 am, A and B both of them are open. A and B both of them are open. So they will be working with the efficiency of what? 3 liters per hour plus 1 liter per hour. That means 4 liters per hour. I hope that's fine with you. See, A's efficiency is 3, B's efficiency is 1. And after 11, B also open and A is not closed, right? So total efficiency in this case will be A plus B, 3 plus 1, 4 liters per hour. How much time are they going to take? How much time are they going to take to complete the remaining work, which is 3 liters? How much time are they going to take? They are going to take 3 work upon efficiency. Yeah, work upon efficiency. Remember? if you want to find time, then you hide time and you have work upon efficiency, right? So how much time are they going to take? 3 upon 4, and the unit of time is hours here. Okay, well, that will not get you the option, because options are in terms of what is the time in your watch, right? So is it 12:45 a.m., 5 p.m. and blah blah blah? How will you get to know? You will get to know, okay, so here you have remaining work. Okay, yeah, you have remaining work, that is 3 liters, and you are able to complete that into 3/4 hours. Now if I convert that into minutes, I have to multiply by 60, because 1 hour is 60 minutes, right? That will get you 45 minutes, right? 3/4 hour, that means 45 minutes, okay, if you simplify. Okay, so after 11 a.m. you got another 45 minutes. That means the time now should be 11:45 a.m. Did you understand that? I hope yes. So whenever the situation is changing, you should look at the situation at the time when it is changing. So at 11 a.m. be open. So first see what is happening between 10 to 11, and then remaining work has been done working together. So that's how you solve. So I hope you are clear with this solution. I hope you like this. So this is it in today's video. My name is Shah Manawat, signing off now. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.